Thank you for joining this lesson. We're going to discuss area approximation together with exact area by integration. Remember to subscribe to this channel and to also share the link with friends. In number 24, we're told that the figure below shows the area bound by the curve y equals to 5x minus x squared in the line y equals to x. So we have the line y equals to x here, the curve y equals to 5x minus x squared as shown. Find x, the value of x at the point of intersection of the curve and the line. So where the two intersect, we can solve them simultaneously. At that point, y is equivalent to 5x minus x squared, and also y equals to x. Therefore, we can equate now 5x minus x squared and x, so that if we start grouping like terms together, we can bring x here to have 4x. Then we have a negative x squared equals to 0. This means now we can solve this one, whereby if we factor out x, we shall remain with 4 minus x equals to 0. So x is either 0 or x equals to 4 equals to x. Yeah. So we see now the curve and the line can intersect at two possible points where x is 0 and it's here. So the other value here, it means the value of a now equals to 4, because this is the other value. At x equals to 0 is the point of intersection, which is at the origin, but now the other intersecting point is x equals to 4. We can finish up by getting the coordinate, because at that coordinate y is equal to x, then we know that the coordinate, if this was to be written as a coordinate, let's say point P, it would be 4, 4. Yeah, that is coordinate 4, 4. All right, let's now continue. Part B, using the trapezium rule with 4 trapezia, estimate the area of the shaded region. So from 0, we should have 1, 2, 3, then 4. Yeah, so the trapezia are going to be here, the second one, the third one, and the fourth one. These are the 4 trapezia. We're going to use them. Let's get the values of y at the respective values of x. With this table now, I'm going to start at 0, 1, 2, 3, 4. So when we substitute in the curve, x equals to 0, the value of y will be 0. X equals to 1, 5 times 1 minus 1 squared, we're going to get 4. We substitute 2, we'll get 6. Substitute 3, you get 6 again. And you substitute 4, you also get 4 again. So these are their values. And the trapezium rule estimates area using the formula half h into the first y plus the last y, then plus 2 into all the other y's now, all the other y's added. So that's how we get the area. That means using our formula, we need half. The height is the interval between the trapezia, which is 1. The first y is a 0, the last y is a 4. Then we add 2 multiplied by the other y's, 4, 6, 6. So now we're going to have area. Remember, we are getting area under the curve and the x-axis. Area between the curve and the x-axis up to the line x equals to 4. We are getting all this area. We're getting all this area. This is the area we are getting now using the trapezium rule. That is what we are calculating now. So let's wind up. This is a 0.5. Then we will have 4 plus. This is a 16 by 2. 32 plus 4, 38. Yeah. 38. Really? This is a 10, 16 by 232 plus 4, 36, sorry. 36, giving us 18 square units. That is the estimation of area under the curve and between the x-axis to the line x equals to 4 using the trapezium rule. Now, for us to get the shaded area, there is something we should do, and we should just notice that now there is a triangle here which has to be subtracted. A triangle whereby the area of the triangle is half base times height. So we need half times 4 times 4 because x is from 0 to 4 and y is also from 0 to 4. So we have 4 units in each case. This gives us 16 divided by half or divided by 2, giving us 8 units again squared. That means for us to get area now of the shaded, we need 18 square units minus 8 square units to give us 10 square units. So that is the area. By integration, calculate the exact area of the shaded region. Now we need to first of all, we integrate from 0 to 4 the function 5x minus x squared with respect to x. That will give us the area between or under the curve bounded by the x-axis and the line x equals to 4. That is what we get. Then again we subtract area of the triangle. So we're going to have the power becomes power 2 now. So 5 out of 2 and x is also power 2 minus the power becomes 3. So a third and x is power 3 plus x plus a constant, that is this from 0 to 4. So when we substitute 4 first, we're going to have 5 over 2 into 4 squared minus a third into 4 power 3 plus c. Then we subtract, when we substitute 0, 5 over 2, 0 squared minus a third, 0 cubed plus c. So this is going to be 18 and 2 over 3 square units plus c minus c on the other side, whereby we get exactly 18 and 2/3 square units. So using integration, we are getting 18 and 2/3. But now we have to subtract the triangle again, whereby we can also get, because that is the area now between the curve, the x-axis and x equals to 4. We have already calculated all this area. We can subtract the triangle, whereby it is the area between the line here, the x-axis, and the line x equals to 4. That means we can also integrate the line such that when we integrate the line y equals to x with respect to x from 0 to 4, then we're going to get half, because x becomes power 2 now, plus a constant. This is from 0 to 4. So when we substitute 4, we're going to have half into 4 squared plus a constant minus half into 0 squared plus a constant. So this will be 16 over 2. So 8 plus c minus c, which will be 8 square units. And this means now the final area will be 18 and 2/3 minus 8, giving us 10 and 2/3 square units. 10 and 2/3, the exact area, but using the trapezium rule, we add 10 square units exactly. Thank you for following. Subscribe and share.